Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 15 for the March Daily LeetCode Challenge, and we again have a question which is on the topic of binary search. Like from the last few days, around 4 to 5 days it has been till now, and we are getting very good questions on the topic of binary search. This is one such question. Here, after seeing the question, I am sure that you will after seeing the question, you may feel it is going to be a DP solution. You may feel it can be solved using recursion or DP with memorization. You can think of that, but the idea here is the way the constraints are defined you will not be able to solve it using DP. Okay? That is the basic reason. And one more thing is, I will be showing you a better solution, even better than what the lead code has given. Okay, so I will be showing you why my solution is better than lead code solution because of the way the things are defined. And yep, so let us quickly begin with this. So see, again, like the question is slightly bigger, so I expect that you read the question once and then come back and start resume from here onwards. Okay, the question link will be in the description. Please take it, read it once, and obviously I will be again highlighting the important points here we have to focus on. Okay, so in this question what we are doing is, see, first of all, this is the part fourth of a house rubber question. It's a very good question series, basically house rubber series. You can try it. It's mostly like if you see the house rubber part one, part two, all those things, especially the part one, it is based on a DP. Okay, if you solve using DP, you will be able to get 100% solution. Okay, 100%, like the solution which beats 100% of the test cases, 100% other solutions. So try those things if you have time, and then come back to the fourth version. So the current question that we are discussing is the fourth version of house rubber series. Okay, again, in this what is happening, the core concept remains the same. Only thing is they've added some more constraints here. The first thing is that, see, these are the houses. Okay, these are the some of the values. See, each value here presents the number of dollars present in a house. Okay, so these are the various, you can think of the dollars present in each of the houses. Okay, in the house number one, this is the much dollars are present. In house number two, this is one dollars are present, so on. Okay, what the aim of the robber here is to obviously rob. Okay, but the thing is, the robber cannot go and rob adjacent houses. Okay, so if they rob two, they cannot go for three, right? They cannot go for three. Similarly, if they go for three, they cannot go for five again. Okay, they have to go for nine directly. So that is the basic thing. Now, one more important part is that, see, now they have made the question very tricky. See, they are saying that, first of all, they are defining a capability of a robber. Okay, what is the capability? Capability means, see, there is also a value k given. Okay, what k means is that the robber has to rob at least these many houses. Okay, for example, see, in this case k equal to true. So let us see one option. Okay, it can go for robbing three, and then it can go for this $9. Okay, three and nine. So it has completed k now. Okay, once it completes k, see, there are multiple ways to complete the k. There are multiple ways to rob the k houses. Okay, in each of those ways, we will have to see what is the maximum amount the robber has robbed from a particular house. Okay, that is what is called the capability. The capability of the robber is the maximum amount of money he steals from one house of all the houses he robbed. Okay, we'll see, like in the example number one, we'll see a detailed view of what it means, but just understand that, see, there are k ways to rob the houses. Okay, so we have to go for all the k ways, and see, for each k, okay, obviously there will be multiple houses involved, right? There are k houses involved. In each of those k houses, we have to see like what is the maximum amount that was robbed from a single house. Okay, we have to record all those amounts, and at last, among all those amounts, we will have to find the minimum. Okay, the k representing the minimum number of houses the robber will steal from. Okay, yeah, it is always here. Then we have written the minimum capability of the robber out of all the possible ways to steal chaoses. So I'm sure you would not have understood this because I see, that's why I tell, again, go through the question then come back. So these are not the kind of questions where you can simply watch a video and get every insight of it. Okay, you will have to spend some time. You will have to understand some point. Okay, I cannot cover everything in one video. My aim is to show you the logic building and the solutions. Okay, my aim is not to clarify the questions here. Okay, I'm only highlighting some of the important points. So let me quickly go to example number one first. So see, it is 2359. So okay, let us quickly focus on what are the, see, k obviously equal to 2. Okay, I'm not writing that. Okay, let me write. But yeah, you have to just understand that k equal to 2. So we will try to see what are the various ways in which we can rob two houses. Okay, the first could be 2 and 3. Okay, I could rob 2 and then 5. Okay, 2 and 5. Okay, the other one could be I can go for 2 and then I can go for 9. Okay, so see, 2 here and 9. Remember, we cannot rob adjacent houses. Okay, that is the first point. Then I will go for 3. If I go from 3, it will be 3 comma 9. Okay, that is the only option because I cannot rob 5 after that. Okay, and after this, if you see, there is no other option. If I go for 5, I will not be able to complete 2. Okay, remember, we have to complete two houses. Okay, the robber has to rob two houses, only then all this whatever they have mentioned will be applicable. Okay, if we are not able to rob two houses, then these things will not be applicable. Okay, as simple as that. So these are the only ways in which we are robbing from adjacent, we are avoiding to rob from adjacent houses. That is the point number one. Second point is that we are completing k robbing. Okay, as simple as that. We are robbing k houses. So let us quickly see among them. See, first of all, you have to maximize this value. Okay, you have to maximize the capability now for each of the robs. So in this, what is the maximum value, by the way? In this, the maximum value is going to be 5. Similarly, in this, the maximum value is going to be 9. Okay, I'm writing 9 here. Okay, in this, the maximum value is again 9. Okay, I'm writing 9 here again. Okay, so among these maximized values, okay, 5, 9, and 9, you will have to now write the minimum value. Okay, So among 5 comma 9 comma 9, you have written the smallest value, okay, the minimum value. So in this case, the minimum value is 5. 5 is going to be the answer, okay. So this was the question. If you have not answered this till now, please pause the video, go through the question, go to the examples. I have, tried to show you the example number 1. They've also shown it the same way. You can go through that. They've given the indexes also. You can go through that, but I felt like giving index is not a good idea. I've directly given the values to you, okay. Go through that. If you have any questions, please do let me know. But again, this question is all about this. I know this is slightly tricky, but this is all it is, okay. So first of all, you have to maximize the capability in each of the robbings, and then at last, among all the maximized values, among all the maximized capabilities, you will have to find the minimum capability. Okay, that's what they're mentioning, minimum capability. So this is kind of question where we are finding the min of the maximums. Okay, minimum of the maximums. Okay, as simple as that. So for all these kind of questions, see the what LeetCode says is that for all these kind of questions, there's always a possibility to solve using binary search. That's what they have written. Let's see how it works. But before that, I will be showing you the recursive solution. This doesn't work. I know that this doesn't work, but I just want to show you because I have it ready. So I just want to go through it to understand how this works, because in many solutions this will be working. Remember, in I think in the last one itself, we had a long series where we were solving questions using backtracking. Okay, especially the question which have the lexicographical component, there you will always have to think about the recursive solution always. Okay, that will always be a possibility to code it using recursion. Okay, so I will show you quickly. See, what you're doing is this is a recursive function. Okay, so what all I have to do, and see, I'm creating answer which is initialized to the infinite value, okay, and then I'm capturing the length of the nums, and then this is a recursive function. What is a recursive function? Recursive function is something that calls itself, okay, simple as that. So this is the first recursion call, okay, this is the first call to this function, and we are passing values 000. What are these values? Let us see. First is the index, second is the max value we've seen till now, and similarly the third value is the how many houses we have robbed till this point, okay, as simple as that. So if so these are some of the stopping conditions. These are the base conditions for a recursion. If this condition are true, the recursion will be stopped. Okay, there are two such conditions here. This is the condition number 1, and this is the condition number 2. Okay, let's go through each one of them. Yeah, the first condition is that if the index has reached greater than equal to 1, that means we have covered all the values. Now there are no more values to cover. Okay, in that case, there is again a if condition. If the house is robbed is greater than equal to k. Remember, only if the houses robbed are greater than equal to k, only then we can capture the max. Okay, if that is the case, we will have to capture the max. So whatever is the max we have got till now, compare it with the answer, whichever is the minimum that you store it in the answer. Okay, as simple as that. But whether this condition is true or not, still we will have to return. Okay, because this is a stopping condition. So if this condition is true, return will have to be executed. Okay, as simple as that. The second condition is optimization. See, basic idea here is, see, as they mentioned, you cannot rob adjacent houses. So see here, let us say I start with 5. Okay, 5 is going to be my first house that I'm going to rob. But see, can I complete 2 robbings if I start with 5? That is the question, right? See, if I rob 5, I cannot rob 9 because that is the adjacent house. But after 9, there are no houses left. Okay, so I cannot complete k robbings. So that is the reason why I've added this condition. If n minus index, this tells us how many houses are yet, like including the current one, how many houses are pending to be robbed. And similarly, if this is less than k minus houses robbed, in that case, it will not be possible to rob k houses. So that's why we are simply returning. We are not proceeding with this particular recursion tree. Okay. Now there are two options left. Either we can skip the current index, or we can rob the current. That is, we can skip the house which is marked by this index. Similarly, we can rob the house which is marked by this index. So if we skip the house, what will happen? See, we'll again call the same function. In this case, only the index is incremented. The rest all remains the same. Okay, the max we have seen till now remains the same. The house was robbed we have seen till now remains the same, because from the previous call to this call, only thing which is changing is the index. Okay, so it will be like this. In the other case where we are actually doing the robbing, what will happen? See, we'll have to compare nums of index with the max we have seen till now. If there is any change, if there is difference in the maximum values, we'll have to update the maximum value to this. Okay, simple as that. Then index will be changed to 2. Why to see? As I mentioned, adjacent houses cannot be robbed. Okay, so if we rob the current house, we'll have to start again with plus 2 index. Okay, index plus 2. We cannot go to the next index directly. Here we are going to the next index. Here we will have to go to the plus 2 index. Okay, and then the max, and then this time the houses robbed will be incremented by 1. Okay, because there is additional house that is robbed compared to the previous function call. Okay, so this is how it works. And initially I'm passing 000 all. Okay, and finally I'm returning the answer. As you can see here, the answer is getting incremented. One more thing is, always declare non-local whenever you're referring something which is declared outside of the scope of the current function. Okay, in Python we can have a function inside a function like this. This is a function inside this function, but all these values are declared outside this function. Okay, that is why in this function I'm writing non-local of these things. Okay, as simple as that. So this is one such solution. This will not be working. This will give you time and exceeded error. So let us go and see which solution works. Okay, this is going to be the binary search solution that I'm going to show you. See, why the idea of binary search comes. Well, let me tell you this. My solution is completely different from what LeetCode presents for this. My solution is totally based on what I feel is going to be the right way. See, first thing is, what I'm doing is, see here the thing is, they are mentioning certain values. Okay, these are the dollars present in each of the houses. This could be same. Okay, there is no such condition that all the houses are going to have unique number of dollars. Okay, there is no such case. Even in reality, that will not be the case. Okay, so that is the reason now the first thing that I felt will be the best thing to do is I have created a set out of this, and then I have sorted those values. Okay, so I have stored those sorted values in a new list called sorted nums. Okay, this list is completely different from my original nums. Okay, the original nums have only the original elements, but this will have the unique elements in a sorted way. Remember, the things are two things are here. Okay, first is unique, second thing is sorted. Okay, the unique values will be collected and sorted. Okay, so if there are any repetitions, okay, let me show you the output first. So this is how it will be. Let us go to, yeah, if you see here, obviously in this there are no repeating values, but there can be repeating values. Okay, I've tested that there can be repeating values. Once we are sorting it, it will be looking like this. Okay, now you will ask me why we need to sort it. Okay, yeah, the answer here is C. The way it is defined, right? See, the, we will have to return. See, we are ultimately going to return the minimum value, right? We have to find the minimum value. So we have to see, like, see, whenever it's k is mentioned, k means that, see, we have to find a number. For example, 5 in this case, 5 should have at least one value lower than that. Okay, in this case 2 or 3. Okay, see, 2 and 5. Okay, because k equal to 2, right? So k equal to 2 means whenever you're selecting number, okay, remember we have to take the maximums. Okay, we have to take the maximum. So for each number we need to see, okay, how many numbers are below it. Okay, including itself. Okay, so we'll have to see that. Okay, when k equal to, that means for any number we need to find one more number which is less than that and not adjacent to that. Okay, if you're able to find that, then we have got a possible answer. So that's what we are going to do. See, I've created the sorted nums. I'll print the assignment show to you now. Then this, I'm defining this particular function. So what this function does is that, see, once I pass a value, okay, once I pass a value, the value will be one of these values. What I will try to see is whether I am able to collect, okay, five values which are less than or equal to this particular value, such that they are not adjacent. Okay, that is the task that I'm going to do. See, I'm writing houses robbed equal to 0. I'm starting from I equal to 0 till I is less than, and I'm doing this. See, whenever I find a value, whenever I find a nums of I which is less than the equal to current value, okay, well, that I passed here, I will do the house robbed plus 1, and I will increment the I plus 1. Okay, remember, this will be additional increment compared to this. Okay, so this will anyway be happening, but if the value is less than equal to val, we will do another time. So the idea here is whenever we find a value which is less than equal to val, the I will be incremented by 2, and similarly in other cases where it is not less than equal to val, the I will be incremented by 1. Okay, as simple as that. Because as you know, right, adjacent values cannot be robbed. Okay, so once we rob a house, we have to go to the increment the index by 2 always. Okay, that is the basic idea. Okay, and once this while loop completes, what we are doing is, if we are checking if the house is robbed is greater than equal to k, then we're returning the true, otherwise returning the false. So this is kind of a greedy kind of approach that we are doing to check whether, once we select a value, okay, let us say I'm going to select 5, so I need to see whether there are two values which are less than equal to 5 or not in this whole area. Okay, that is the basic idea. Okay, that's what I'm trying to check. So this function is for that. This function will return true if, yeah, there are less than equal, okay, there are values which are less than equal to the given value. Okay, k times, and similarly, if it is not the case, it will be returning false. Okay, if we are able to find k values which are less than equal to the given value, only then true will be returned. Okay, simple as that. Now we'll start the binary search. As we know, L will be equal to 0, R will be equal to length of sorted nums minus 1, because remember, here there could be repetitions, but in our sorted nums there will never be repetitions. Okay, all the elements will be unique and they will be sorted. Okay, remember, for doing a binary search, it's always important to ensure that the search space is sorted. Okay, that is the foremost thing that you should ensure. So I'm sorting it. This will go from see, the index number 0 till the last index minus 1. Okay, now while L is less than, see, this whole part is exactly same as what I've shown you yesterday or even the previous days. Okay, this is exactly the same. While L is less than R, we are doing this. We are calculating the mid. How this mid is calculated, I have explained it in the previous video. From, we'll add a value to the L. Okay, what is that value? It will be R minus L whole divided by 2. Okay, this is an integer division. Remember that. Okay, because mid has to be integer. Next, we will now pass. See, in this function, we are passing sorted nums of mid. Okay, that is, we are passing the value which is present in the index equal to mid for sorted nums. We are passing that value to the function. Okay, to this particular function. So what we are trying to check is whether, for the given value, whether there are k values less than equal to it, less than or equal to this particular value or not. Okay, such that they are not sent. I will again repeat, this value is being passed. What that means is, if this function returns true, that will mean that we are able to find k values which are less than equal to the given value, such that those values are not adjacent. Okay, as simple as that. If that is the case, we have to ultimately minimize, right? We have to minimize. So once this condition is true, that means we have got a possible answer, but we'll have to see whether even lesser answers are possible or not. Okay, So we'll do r is equal to mid minus 1. So we are trying to reduce our search space. That is the first point. Second point is that we have found a possible answer. So answer is equal to sorted nums of mid. Okay. So in this particular index, that is the index equal to mid, whatever is value is present in the sorted nums, that we are going to store in one of the possible answers. Okay. If this is not the case, let's say if this function returns false, that means we have to increase our value. In that case, what I'm doing, L is equal to mid plus 1. Okay. As simple as that. Once this whole loop completes, we have to return the answer. Okay. So if you compare this complexity, see, I will go in a very generic way. See, the complexity, as you can see, for the binary search, it will depend on the value. Okay, see the nums of, if we compare, okay, it is going to be around, okay, yeah, first of all, not the nums of I. See, in this case, what I'm doing is nums of I is basically coming from this. Okay, so the length of this is coming, so it will coming from this. Okay, so in general there are going to be 10 power 5 elements, but if you take the only unique ones, maybe it will still be 10 power 5. So for the binary search only alone, it is going to be around 10 power 5. Okay, because I'm talking about log n. Okay, so it is going to log of 10 power 5. Okay, only for the binary search. And since in the binary search this function is being called, okay, in this function if you see, we are doing a whole O of n loop. Okay, so it is going to be n log n, where n is the nums of the length. Okay, but if you see the official solution, they are also doing something with this. Okay, they are going for the maximum value of the numbers present. Okay, which is 10 power 9. Okay, I felt that it is not a good idea to go for it. See, it's very simple. See, I could have done is, see, I need not have created a extra array. Okay, I could have used the same array, nums array itself. In that case, what I would have to do, I would have to write, r is equal to max of the element present in the nums. Okay, but the idea here is, if I do that, I will, the log, that is log of n that will come, will be having this. Okay, in this case, it will be log of 10 power 9. But the way that I have implemented, I have created additional array. The idea behind this is that, see, this 10 power 5 is less than 10 power 9. Okay, there is a huge difference between them. Okay, so instead of going for the 10 power 9, I'm going for 10 power 5. Okay, if you see the official solution, they are going for a 10 power 9. So they are saying like it will be n into log 10 power 9. Okay, because see, I'm comparing the worst case, right? 10 power 9 is basically the highest value that can occur. So if you are doing a binary search from 1 till 10 power 9, so it will have around log of 10 power 9 iterations. Okay, so that is going to a very high number. So I'm trying to reduce the same. So what I'm doing is I'm creating a separate array for that. Okay, in this case the length is going to be 10 power 5. So now my binary search will be for 10 power 5. Okay, so I'm 0 to 10 power 5. Okay, as simple as that. So because of that reason, I'm able to save around 10 power 4 directly. Okay, if you see here, it's 10 power 5, it's 10 power 9. So 10 power 4 directly, even without starting the solution, I'm able to save that. Okay, as simple as that. So my solution will be n log n, where where n is actually 10 power 5. Okay, as simple as that. So yeah, and that was all for this particular video. This was a very, see, this question, I will say that, see, there are not multiple ways to solve this kind of questions. Many of you would have tried DP. I know that. Even I tried the same. As I've showed you, I've also tried the same. This is not DP, but a recursive solution where we are doing not even trying to cache. I've not shown you the caching part here, but I have tried that. Okay, even that did not work. Okay, that's why I did not proceed further. But again, even after caching, it will not work. So there are not multiple ways, but yeah, the question looks like it's going to be DB question, but it was not the one. Okay, because of the way the values are defined, 10 power 9, 10 power 5, all that. Because of that, this will not be a DP question. Okay, and yeah, you can solve using binary search. But again, this is not something that I will say everyone will be able to follow. They will need a lot of hints, and especially this part. Okay, I myself agree that to see, this is a greedy algorithm. It may not have always worked. Okay, to code this kind of solutions, it's always important to take a pen and paper and test every case out. Only then you can come to this kind of solutions. Okay, especially this part is something that even I was not confident about, but yeah, it worked. So yeah, and that was all for this particular video. Whatever I could have shown you, this question was not something where I can expect people to come and solve it. There's not such a question. There's not much thinking involved in this. This is something like, if you try binary search and you get it, then it is fine. Otherwise, you are not able to solve it. Okay, so this is not a good question for a interview. That's what I will say. But yeah, the previous questions were really good. This is not a very good question according to me. So yeah, that was all for this video. And if you like my efforts, please do subscribe to the channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.